Okay, now let's talk about the two types of reasoning that we use when we do problem solving. The first reasoning that we have is what we call inductive reasoning. Now, inductive reasoning is simply the process of us reaching a general conclusion when we examine specific examples, specific procedures, or even specific principles. Now, when we use inductive reasoning, logically, whatever conclusion we generate will always be true. But realistically speaking, it may or may not be true, or it may or may not be correct. That's why any conclusion that we generate by using inductive reasoning is what we call a conjecture. So conjecture is a conclusion that may or may not be correct. Okay? Now let's try to use inductive reasoning to make a conjecture. Again, when we use inductive reasoning, we use specific examples. Rather, we examine specific examples to draw out a general conclusion. So now we have here a procedure that says that we have to pick a number, multiply the number by 8, add 6 to the product, divide the sum by 2, and subtract it by 3. Now again, when we use inductive reasoning, we need to have specific examples. So the first step of our procedure of picking a number, we have to pick a specific number. So let's say I pick number 1. Okay, I pick number 1. And now I have to do the procedure. The next step of the procedure says that I have to multiply the number that I chose by 8. So that's 1 times 8, which would give me 8. And I have to add 6 to the product. That's 8 plus 6 will give me 14. Divide the sum by 2, so 14 divided by 2 would give me 7, and then subtract 7 by 3 would give me 4. Now, is this enough for us to draw a conclusion? I think not. That's why in the definition of inductive reasoning, it says that we have to use specific examples. The example is plural, so we need to add at least one more before we generate or before we try to come up with a conclusion. So I'll choose again another number, something simple like 2. So doing the procedure, I have to first multiply the number that I chose by 8. So that's 2 times 8 would give me 16. And then I have to add 6 to the product. So 16 plus 6 would give me 22. Okay, divide 22 by 2 would give me 11, and subtract 11 by 3 would give me 8. Now, two examples I think is already enough for us to come up with a conclusion, but let us try to be safe. No, let's try to be safe and add one more. So what's another easy number that we can use? I think it would be 3, right? So doing the procedure again, 3 times 8 would give me 24. And then I have to add 6. That would give me 30. 30 divided by 2 would give me 15. And then 15 minus 3 would give me 12. Okay. Now look here on the left. These are our original numbers, the numbers that we chose on the onset. We chose 1, 2, and 3. After doing the procedure, 1 became 4, 2 became 8, and 3 became 12. Now, what conclusion can we generate out of these examples that we have? Well, the conclusion that we could come up, no, I hope you arrive at the same conclusion, is that whatever number we choose in the beginning, after doing the procedure, it gets multiplied by 4. 1 times 4 is equal to 4, so that's correct. 2 times 4 is equals to 8, so after doing the procedure, 2 became 8, so the conclusion is still true for our second example. And for our last example, does 3 get multiplied by 4? 3 times 4 is equal to 12, and after doing the procedure, indeed we had 12. So the conjecture, again, since we are using inductive reasoning here, um, conclusions that we get out of using inductive reasoning are called conjectures. So the conjecture that we have for this procedure is that the original number gets multiplied by 4. Okay, so that's how we use inductive reasoning to make a conjecture. Now, if inductive reasoning, you have specific examples to draw out a general conclusion, the opposite is true for deductive reasoning. Deductive reasoning is simply the process of us reaching a specific conclusion by using or by applying general assumptions, procedures, or principles. Okay, or when we use general examples to draw out a specific conclusion, then what we are using is deductive reasoning. Okay, so if inductive is from specific to general, deductive reasoning on the other hand is from general to specific. Okay, now let's try to use deductive reasoning to make a conclusion. We also have a procedure here, and it's also just the same procedure that we used in our inductive reasoning. But here, let us try to generate the same conclusion that we had earlier. What was our conclusion just a few seconds ago? The original number gets multiplied by 4. We need to come up with that same conclusion. But in this procedure, we have to use deductive reasoning. So how do we use deductive reasoning to generate the same conclusion? Again, recall what was the definition of deductive reasoning. Deductive reasoning is simply the process of us reaching a specific conclusion by using general assumptions or general examples. Now, how can we have a general example in this procedure? Well, what was our examples in our inductive reasoning? Our examples was, or rather, our examples were specific numbers, right? We chose 1, we chose 2, we chose 3. But here in deductive reasoning, we need to have a general example. And how can we have a general number? If we have a variable that represents that number. So let's say we pick a number, but let us have a placeholder for this number. A random variable, let's say n. Okay? N here would represent our general number, general example, right? Any number can be n. So that's general, that having n here generalizes that example that we have. Okay, so let us try to do the procedure using our variable. We have to multiply the number by 8, so 8 times n would give us 8n, and then add 6 to the product, so 8n plus 6. Okay, divide the sum by 2, so we have to divide this by 2, which would give us, which would give us 4n plus 3, right? 8n divided by 2 would give us 4, and 6 divided by 2 would give us 3. And then we have to subtract this by 3. So this cancels out our constant, and now we are left with 4n. 4n means 4 times our general number or original number, right? And what was our conclusion? Rather, what was our conjecture in our inductive reasoning? The original number gets multiplied by 4, and this is represented by that conclusion or that conjecture. Therefore, using deductive reasoning, we have proved that the conjecture that we have earlier is correct, right? And our conclusion here using deductive reasoning is that the same. The original number gets multiplied by 4 after doing the procedure. Okay? Same procedure, same conclusion, but different type of reasoning to come up with the conclusion that we have: inductive reasoning and deductive reasoning. So to recap what we have with inductive and deductive reasoning, inductive reasoning would always be logically true, but realistically may or may not be true. That's why conclusions that we use, the conclusions that we generate when using inductive reasoning are called conjecture. So we have again specific argument to draw out a general conclusion. Deductive reasoning, on the other hand, would always be logically true and realistically true because we have a general argument, a general principle, a general assumption to reach a specific conclusion. Okay? Last exercise before this video ends is that we have to determine whether the following arguments that we have is an example of inductive and deductive or deductive reasoning. So the first example or the first statement that we have: during the past 10 years, a tree has produced plums every other year. Last year, the tree did not produce plums, so this year the tree will produce plums. Now I give you 2 seconds, 2 to 5 seconds. What do you think is the reasoning that we are using in this statement? Okay, the reasoning that we use in this statement is inductive reasoning. Why is it inductive reasoning? Because the conclusion that we have, okay, the conclusion that we have, this year the tree will produce plums because last year the tree did not produce plum, is based on specific examples. And the specific examples that we have here are the years when the tree did not and did produce plums, right? So that's why we have here an inductive reasoning statement or argument. Now, for letter B, and again 2 to 3 seconds after reading the statement, try to guess what reasoning we have here. All home improvements cost more than the estimate. The contractor estimated that my home improvement will cost 35,000 US dollars. Thus, my home improvement will cost more than 35,000 US dollars. Again, 2 to 3 seconds. What is the reasoning that we used for this argument? Okay, what is our conclusion? Our conclusion is my home improvement will cost more than 35,000 US dollars. This conclusion is drawn out by having a general argument. And our general argument is that all home improvements cost more than the estimate. So when my contractor estimated that my home improvement will cost 35,000 US dollars, the specific conclusion that I came up with is that my home improvement will cost more than 35,000 US dollars. So therefore, this statement here or argument here, we use deductive reasoning. Okay? And here again we use inductive reasoning because we have specific examples. Okay, this is our specific example and this is our general conclusion. For the statement B, this is our general example, all home improvements. That's a general statement. And then we came up with a specific conclusion in terms of my home improvement, right? General is all home improvement, specific is my home improvement. Okay, so from general to specific, that's deductive reasoning.